In this demo, we are going to learn how to control a brushless DC motor. As you can see, this brushless motor has been connected to a propeller. This can be used for a RC, airplane, or hydrocopter, and so on. And this brushless DC motor, it is controlled by ESC, where ESC stands for Electric Speed Controller. And this particular demo, we are using a RC radio controller to send the PWM signal to its receiver. This is the transmitter sending the signal, and here is the receiver receiving the PWM signal, send it to the ESC, control the speed and even the direction of this brushless motor. For this demo, the power for this system is our LiPo battery. Of course, you can also use DC power supply as a power source for testing the system. For this demo, I used 3300 milliamps hour LiPo battery. However, LiPo battery is explosive. To reduce the risk, I will put this inside a battery bag. So in case anything happens, and then at least is exploded inside the bag, it won't damage our system. Okay, and at the same time, here there is 3 wires coming out from the ESC, connects to the positive, ground, and the yellow wire in my case here is the control signal, which is the PWM. And then I'm particularly interested in that signal's shape, the shape of the signal. So I connect that control signal to the scope probe. And this scope probe attached to channel 1 of the oscilloscope. We want to visualize the PWM signal. How about now? Let me connect the power source. So there and here, make sure they are connected. Once you hear the sound, that means great, it's working. And then now, let me turn on the RC, the radio controller. I have already synchronized this with the receiver. But now, let me turn this on. They are synchronized. As you can see, the speed is very fast. So here, they are synchronized. I did it before the demo. And then just turn on the throttle. The motor turns on, and then we have PWM signal. Let's stop here. As you can see, this is the PWM. And then now I'm going to increase the throttles. The PWM signal also increased. How about this? Let's change the scale. It doesn't change the signal, just the way it looks. And then I make it stretched. This is the PWM. And currently the motor is now spinning. There you go. And now I'm going to increase this throttle again. Let's see how this is changed. It was such a high speed, and then my throttle only reached to perhaps 20% of the whole range, and that already produced a super high speed. With that speed, and I only reached to 30% of the entire range, I'm very worried what happens if I change here all the way to 100%. I'm not going to demonstrate that in this demo. It is possible to push this all the way to the end, but I'm not going to try it. I only let it reach to 20% of the range. And the PWM waveform stretched, which means the duty cycle increases.